All right, greetings everyone. Welcome to the third part of the video now for section 5.2, continuing on with our study of angles. And we ended the last video about talking about a way of measuring angles called radians. So we're going to continue with that in this video. Okay, so in the last video, we talked about this kind of crazy formula of to find the radian measure of an angle, you have to do the ratio of the arc length to the radius, and you get some number, but then Cody said something crazy about how it doesn't matter what the radius is, you always get the same answer. So what's that all about? Well, it turns out that to find the radian measure of a particular angle, we don't have to go through that long process or kind of theoretical approach. And in fact, we can use the information we found in the previous video as kind of a conversion factor to help us convert between angle measures that are in degrees and angle measures that are in radians. So in the last video, we found that for an angle measure of 180 degrees, the equivalent measure in radians was pi, or pi radians. And notice in this case, I don't have to write radians in there, I just write pi. And so because of that, we can create a conversion factor, if you think about if you've done dimensional analysis before, that is 180 degrees over pi. Or depending on how we're converting, we might need to use one that is pi radians over 180 degrees. So that equivalence there allows us to convert between the two different types of angles. So let's look at using that with the angles down below. So first given 120 degrees, since that's in degrees, we're going to convert to radians. I'm going to do this by first putting that 120 degrees over 1. And then I need to decide which of those two conversion factors from up above, the 180 degrees over pi, or the pi over 180 degrees, that I want to use. Now, since I'm trying to go from degrees to radians, I want to choose the one that's going to allow me to cancel out my degrees. And so in this case, because of that, I'm going to use the pi over 180 degrees. And notice that what that allows us to do is we can cancel the degrees here and here. And then we're just multiplying with two fractions. And we multiply with fractions, we can multiply straight across. So we do 120 times pi, which is 120 pi, over 1 times 180 would be 180. So we have 120 pi over 180. I think the 120 and the 180 can reduce, so cancel out the zeros here. 6 will go into 12 twice, so that'd be a 2 pi over 6 goes into 18 3 times. So it looks like the radian measure for 120 degrees then is 2 pi over 3. All right, so that's going from degrees to radians. Let's now go from radians to degrees. Now this one right here, the pi over 8, I know this is in radians because first of all, I don't see a degree symbol. Also, I see the pi, which is a giveaway. It's not always, when we have pi does not always mean we have radians, and just because we don't have pi also doesn't mean we don't have radians. But in this case, this one is radians. And so we need to convert this into degrees. And in this case, we'll use our other conversion factors, so the 180 degrees over pi. And notice one nice thing that does, first of all, is cancel out the pi's. And then we still have the degrees, so that's good because it'll give us the answer in degrees. So we'll have 180 degrees over 8, which we can reduce, or in this case divide, since I think this will come out kind of nice. And we end up with 22.5 degrees. Okay, so you see pi over 8, that's the same as 22.5 degrees. All right, now one more thing before we move on. As I was mentioning, when we have an angle measure in radians, we don't always have to have a pi in it. And in fact, sometimes you'll see radian measures given as decimals. So for example, in my calculator, if I do pi over 8, I get 0.3927. And so that's another way of expressing the same angle. So pi over 8 radians or 0.3927 radians, those mean the same thing. So again, as I said before, you won't always see a pi in a radian measure, but often you will. Okay, let's talk about coterminal angles now with radians. And here we're asked to find angle phi such that phi is between 0 and 2 pi. It's coterminal with each of the given angles. And one thing we can check, if we convert 2 pi here into degrees, so we'll use our conversion factor. So 2 pi over 1 times 180 degrees over pi. Notice the pi's will cancel. We have 2 times 180 degrees on the top, which will give us 360 degrees, all divided by 1, which is 360 degrees. So that 2 pi is representing 360 degrees. The 0 radians, as you might imagine, represents 0 degrees. So this is really very similar to the same type of problem we did before with degrees, only we're going to do everything in radians this time. And recall that when we did this in degrees, our approach was either to add or subtract 360 degrees. So what do you suppose we're going to do here if we're going to work in radians? That's right, we're going to add or subtract 2 pi, since that's the same as 360 degrees. Okay, and so in each case, we're going to have to first determine, is this number above 2 pi or below 0 to help us determine whether we need to add or subtract. Now here we have 13 over 4 pi for the first one. And one thing we can do here is we can actually rewrite this as 13 over 4 times pi. That's the same thing. And 13 over 4 gives us 3.25 pi. And notice from that point of view, we have a 3.25 pi. That's going to be bigger than 2 pi, right? So because the measure of this angle is bigger than 2 pi, what are we going to do to find an angle that is coterminal with 2 pi? That's right. Again, we're going to subtract 2 pi. We're going to do this with fractions. We're not going to use any decimals or anything. So we have 13 pi over 4 minus 2 pi. I'm going to make the 2 pi a 2 pi over 1. I'll get a common denominator between the two of these, so that will be 4. Which will give me 13 pi over 4 minus changing the 1 into a 4, multiply by 4, multiply the 2 pi by 4. That'll give us 8 pi. So we have 13 pi over 4 minus 8 pi over 4. When we subtract fractions, we just subtract the top. So we'll have 5 pi all over 4. And 5 pi over 4, that's the same as 5/4 pi, which 5/4 is the same as 1.25 pi. So we are in the correct range. So this would be our answer here, is 5 pi over 4. Okay. Let's do one more example like this, and let's do the number 4 here, the negative 7 pi over 4. Well, notice because this is negative, it's probably fairly straightforward to say that this is less than 0, so we're going to have to add 2 pi this time rather than subtracting it. So add 2 pi to this radian measure. And again, make it 2 pi over 1. We'll get our common denominator as 4. So still have negative 7 over pi plus, change the 2 pi, multiply by 4, we get 8 pi. So negative 7 pi over 4 plus 8 pi over 4, that would give us 1 pi over 4, which is the same as just pi over 4. And hopefully you notice here, with the 1 pi over 4, you see that kind of 1/4 pi. That's definitely less than 2 pi. So it tells us that we have our correct coterminal angle here. Okay. All right, that is it for now. Thank you for watching.